In 2003, astronomers spotted a distant object moving through the outer solar system. At first glance, it looked like another discovery waiting to be added to an already familiar map. The planets were known, the major regions beyond Neptune had names, the broad structure of the solar system seemed settled. Then Sedna's path came into focus. Instead of following the kinds of orbits astronomers had come to expect, Sedna traveled on a route that felt strangely disconnected from everything around it. It belonged to the solar system. It circled the sun, yet its motion did not fit comfortably beside the planets, the asteroids, or the distant objects that had defined the known outer frontier. That immediately created a problem. The solar system was supposed to look finished. Whatever evidence remained from its earliest history should have been erased, scattered, or buried long ago. But Sedna kept moving along an orbit that seemed to preserve something older. Not a message, not an explanation, just a pattern. And the longer that pattern was studied, the harder it became to treat Sedna as just another distant object. Its path suggested that the familiar map might be incomplete, and that one small world was still carrying traces of conditions that no longer seemed to exist. The simplest explanation still seemed available. Maybe Sedna was unusual, but not unique. Maybe it was simply an extreme member of a population astronomers already understood. If that were true, its orbit should eventually lead back to a familiar cause. So the calculations began. Every path in the outer solar system seemed to point back to the same suspect: Neptune. If Sedna was only another distant object, Neptune should have left fingerprints all over its orbit. But when Sedna's orbit was examined closely, something unexpected appeared. It never comes close enough. Sedna travels so far from Neptune's influence that the planet cannot place it onto its current path through ordinary gravitational interactions. The object is there, the orbit is real, yet the mechanism expected to create it never gets the opportunity to act. That changes everything. The explanation does not bend. It breaks. The modern solar system can explain countless objects moving through space today, but one of its own members now sits outside that explanation. Sedna continues following the same orbit, while the process expected to produce that orbit remains out of reach. The problem refuses to go away. Whatever shaped Sedna appears to belong to a set of conditions that are not visible in the solar system we see today. And if the present environment cannot create that path, then the search has to move somewhere else, toward a version of the solar system that no longer exists. The contradiction had not disappeared, but it finally seemed manageable. Instead of looking at the solar system as it exists today, researchers began looking backward. Not billions of years backward in theory, but backward to a time when the young sun may have occupied a very different neighborhood. In that picture, the sun was not isolated. It sat inside a crowded stellar nursery, surrounded by other young stars moving through the same region of space. Distances that seem enormous today could have been much smaller then. Nearby stars could pass closer. Their gravity could reach farther into the outer solar system. For the first time, the orbit stopped looking broken. A passing star does not need to leave behind a visible scar. It only needs to tug on distant objects while the solar system is still young. An orbit shifts. A trajectory stretches. Then the encounter ends, while the altered path remains. That possibility changed what Sedna seemed to be. Instead of behaving like an object the modern solar system could not explain, Sedna began to look like a survivor carrying a record from an earlier environment. Its orbit became less like a mistake and more like a fossil, preserved long after the conditions that created it had vanished. For the first time, the pieces appeared to fit. The solar system looked finished today, but Sedna appeared to remember a time when it was not. The explanation felt solid. Sedna could be a relic from a crowded stellar nursery, a surviving record from a time when the young solar system occupied a far busier environment than it does now. The orbit looked unusual because the conditions that shaped it no longer existed. For a while, that seemed enough. Then more distant objects began appearing. One discovery can be treated as an exception, a strange survivor, a historical accident. But as researchers pushed farther into the outer solar system, they started finding additional objects on extreme paths of their own. They were not copies of Sedna, but they kept creating the same uncomfortable impression. Something similar had happened more than once. Again and again, new discoveries pushed in the same direction. Sedna no longer looked alone. The outer solar system was starting to resemble an archive instead of an exception. That changed the meaning of Sedna. A lone object can preserve evidence from a vanished era. A population of objects creates a different problem. Now the question is not whether something happened long ago. The question is whether the surviving evidence is fully explained by the story already being told. The comfortable explanation starts to come apart. Sedna no longer looks like an isolated clue that neatly points back to a solved chapter of solar system history. Instead, it begins to resemble part of a larger archive, one that still contains pages researchers cannot completely reconstruct. Each new orbit made the history look less complete. What looked like preserved evidence from the past was starting to reveal that parts of that past may still be missing. One object can be dismissed as an outlier. A handful of objects forces a different conclusion. As more extreme orbits appeared in the outer solar system, the question stopped being whether Sedna was unusual. The question became whether those orbits were preserving a larger pattern. That is where Sedna becomes more than a distant world. Its greatest value is not its size, its composition, or even its location. The critical clue is the orbit itself. Unlike many traces from the solar system's earliest history, an orbit like Sedna's can survive for billions of years with much of its original structure intact. Collisions erase objects, geological activity reshapes surfaces, ancient environments disappear. But a distant orbit can remain frozen in motion for enormous spans of time. Sedna behaves less like an object and more like a record. The discovery is not Sedna itself. The discovery is the orbit. Long after the environment disappeared. Long after the encounter ended. Long after most of the original clues were erased. The orbit remained. The solar system we see today is ancient, but much of the evidence from its earliest history has been lost, altered, or hidden. Sedna matters because one frozen path appears to have preserved part of that missing record. The object keeps moving. And with it, a fragment of the solar system's earliest history is still moving too.